All right. So today is lesson 3.3, slope-intercept form. We have to write our I can statement. You guys listen up. Shh. That's not going to work if I have to keep asking you to be quiet. You have your I can statements. They're on this green sheet, but I'm going to go ahead and write it out for you anyway. So lesson 3.3 says I can recognize oh, sorry, that's 3.2. Let me erase that. I can graph linear functions in slope-intercept form. Shh. That's the last time I'm going to ask for those to stop over there, okay? I can graph linear functions in slope-intercept form and identify the slope and y-intercept from an equation that is not in slope-intercept form. From an equation that is not in slope-intercept form. That is 3.3. Oh, the whole screen was frozen. I didn't know that, guys. Sorry about that. So I can graph, you guys have it right here on your sheet, right? You guys should have it right here on your 3.3, your green sheet. I can graph linear functions in slope-intercept form and identify the slope and y-intercept from an equation that is not in slope-intercept form. All right, I'm going to go ahead and slide up a little bit. You guys have that I can statement on your green sheets, 3.3. So linear functions can be written in various forms. Y equals mx plus b is the most common. I want to label the parts of this equation. So this is my slope. It's my rise over my run. This is my y-intercept. It's where I cross the y-axis, and it's represented as the ordered pair 0, comma, whatever b is. Remember, because the y-intercept happens when x equals 0. So that's what it looks like as an ordered pair in a table. X is our input value, and y is our output. So remember, this is a function. You put something in, you get something out. Remember that x and y present themselves as ordered pairs in a table. X and Y's present themselves as ordered pairs in a table. Are we good with that? So this is something that's very important. A linear function has a constant rate of change. What does that mean? Well, that just means no matter what two coordinates you try to count the slope between, it will always be the same. So I'm going to write that. The slope between any two points on the line will always be the same. They'll always be equal to each other, okay? So the slope between any 2 points. You could pick 2 points and your neighbor could pick 2 different points. Your slope should be the same, okay? That's what constant means. Constant means that it's the same everywhere. Daniel, are you with us? Okay. I know it's in Chile. I know it's Chile in here, guys. I'm sorry. I can't control that. Okay, raise your hand if you need more time with that. All righty. So open it up on the inside. And we're going to start with this example right here. It says, write the given linear function in slope-intercept form, and then you need to identify the slope and the y-intercept. You need to identify the slope and the y-intercept. So let's talk about what is slope-intercept form. Good morning, sir. What is slope-intercept form? Hey, ladies and gentlemen, this is Mr. Johnson. He is going to be here as a replacement for Mr. McAllister while he's gone. Did you guys know that Mr. McAllister got called away on active duty? He got pulled to active duty, so Mr. Johnson will be here acting in as like the interim assistant principal.
Active duty as an announcement?
Because he was a reservist Coast Guard, and he got called back to active duty.
He's healthy flooded.
Yeah, perfect. I think that's so awesome.
It is awesome.
Yeah.
Good to see you.
All right, perfect. I'll be here.
Hit my head.
Yeah, no problem. Thank you so much. Okay, so focus. Listen up. Tell me what does it mean when we're writing a function in slope-intercept form? What does that mean? What is slope-intercept form? We just wrote it. You guys did a whole doodle note about it. Good job. So we need to make this equation look like this. So really, what the directions might say sometimes is solve for y. That's the same concept, right? Solving for y, getting y all by itself. That's what we need to do. So how am I going to go about making the equation 4x minus 5y equals 15 look like a y equals equation? How am I going to do that? What would you do first, Lissandro? Subtract what? We have to move that x term. It's got to be on the other side, right? So I have to subtract it. I have to subtract 4x from both sides. Do you guys see that? You have to get the x to the right side. Right now it's not. So when I subtract 4x from both sides, I still have a negative 5y equals. Can I combine 15 minus 4x? Can I figure out what 15 take away 4 is and just put that up there? Yeah? Yeah?
Yeah, it's 11.
Is it?
It is.
Okay. Can I combine those? Are they like terms? Does the 15 have an x on it? No, it doesn't. So I cannot combine those. So it stays negative 4x, and my 15 is positive, so plus 15. I would say that that is the most common mistake that we make when we solve for a different variable, right? You guys try to combine terms that aren't the same. They're not like terms. They don't have the same variables. 15 is a constant. Negative 4x is a variable term. Constants and variable terms can't be combined together to make some like crazy mishmash. Doesn't work like that. Okay, so I'm almost ready. I almost have y all by itself. Right now it says negative 5y. That means negative 5 times y. I want to get y all by itself. What am I going to have to do? That says negative 5 times y. Divide by negative 5. Remember, whatever I do on one side, I have to do on the other side. And it's I say this all the time, every stinking term. Everything gets divided by negative 5. Every single term on the right side, not just the first term, all of them, okay? So y equals, let's see, I see the fraction 4/5. What does a negative divided by a negative give me? A positive, good job. So I have y equals 4/5 x. And what is 15 divided by negative 5? So negative 3, I'm going to write as minus 3. So y equals 4/5 x minus 3. It's asking me what my slope is. Remember that m in our equation represents our slope. What is our slope? It's 4/5. It's the number that's attached to the x term. Yours has a typo on it. Yours says y here. I want you to cross that out and turn that to a b. Do you guys know what I'm talking about? Yours says y equals. Turn that into a b equals, please and thank you. Just write it as b equals. So what is the y-intercept? Because remember that b is my y-intercept. What is it? It's negative 3. So I cross the y-axis at negative 3. That's important. It's important to know what that means, okay? How do we feel about that? Okay, all right, so I'm going to go to the other side of the fold. So I know you guys folded these in half. And I'm going to do this question. So this is just like the one that we just did, except now after we solve for y, we're going to have to graph it, okay? So I still need to get y all by itself. I still need to solve for y. I still have to do that, okay? So when I solve for y, what should I do first? What step do you want to do first, Ken? I'm trying to get y all by itself. What should I move away first? It's much like what did we do on the last one? What term did we move away first? The x term. So how would you move out that x term, Ken? It's a positive 3x. How would you move that to the other side? How would you cancel out a positive 3x? Help him out, Tim. Minus 3x. Minus 3x. So when I do that, I have negative 4y equals negative 3x plus 12. Remember that I cannot combine the 12 and the negative 3x because the 12 is a constant. The negative 3x is a variable term. They are not the same. All right, next step. It says negative 4y equals negative 3x plus 12. What do you want to do, Owen?
I would divide by negative 4.
Divide everything by negative 4.
Everything.
Every single term. So negative 4 divided by negative 4, well, that just leaves me with y. Negative 3 divided by negative 4 is the same thing as 3/4, positive 3 over 4. And then the x is still there. What is 12 divided by negative 4? Negative 3. All right, so this one didn't leave us with blanks. I need to figure out where my slope is, and I need to figure out what my y-intercept is. So, Isaac, what is my slope? It's the number that's attached to the x. It's 3/4. Okay, and that's because since that 3 is positive, that means I'm going to go up 3 and to the right 4. I'm going to draw little arrows, up 3 and to the right 4. I think that's helpful. What about my y-intercept? What is my y-intercept, Tyler? Do you see what the y-intercept is? Negative 3, good job. That y-intercept, remember, is where you begin on the y-axis. I always say B is where you begin. That helps me remember. Hopefully it'll help you. B is where you begin. So where are we going to begin on the y-axis? At what point? At negative 3. So I'm going to go down 1, 2, 3, and I'm going to plot a point right there at the ordered pair 0, negative 3. And then my slope is 3 over 4. So that means I do what, Kenna? My slope is 3 over 4. I lost you for a second. You were totally zoned out. It's okay. My slope is 3 over 4. So how much do I go up? And to the right? Okay, so I'm going to do little like squiggles up 1, 2, 3. And to the right, 1, 2, 3, 4. And then I'm going to plot my point. So once I have my 2 points, this is a linear function. That means I need to connect them with a what? I need to connect them with a line. And I want to talk to you guys about making your lines when you connect your points. First off, I want to tell you that lines have arrows. They go on forever. So if you were taking a quiz or a test and you didn't put arrows on there, I would probably take off a half a point. I'd put a big old circle on it. And I'd put like a question mark around it. Say, where's your arrow? We're not drawing line segments, we're drawing arrows. Okay? Questions? Did everybody go through the points like I did? You drove your line through the points, not just a dot to dot. We're not making dot to dots. We want to go through the points. Through the points, okay? It's not a dot to dot. You feel okay with that? All right, let's move on to our last example. Our last example is kind of like a matching activity, and I put this in here because you have something similar to this in your homework. You have something similar in your homework. So we're going to match the lines, line 1, 2, 3, and 4, with these equations over here. But I'm not even going to look at the equations right now. I'm just going to look at the lines. And I think that we can determine something special about each line. So the first line that I'm going to focus on is line 1. And I want you to tell me 2 things you know about this line in terms of its slope and its y-intercept. Yeah. Negative, negative. That's it. Your slope and your y-intercept is negative. Okay. Let's look at line number 2, which is this line right here. When I look at line number 2, what can you tell me about the slope and the y-intercept for line number 2, Owen?
They're both positive.
Does my graph cross the y-axis at a positive number?
No.
So what's positive?
So the slope.
The slope is positive,
The slope is positive.
but the y-intercept is?
Negative.
Okay, perfect. Perfect, perfect. Let's look at this guy. Oh, that's not number 3. Sorry. I want to go to number 3. Number 3. Let's look at graph number 3. So what can anyone tell me about graph number 3's slope and y-intercept? Slope is positive and my y-intercept is positive. Yeah. And then my last one is graph number 4. I'm going to make that one purple. So here is line number 4. So what can you tell me about the slope and the y-intercept from line 4? Slope. What do you think about the slope, Avery? Is that line going up or is it going down when you look at it from left to right? Say again? Yeah, it's going down. This is the left side. This is the right side. It goes down. So it has negative slope. What about the y-intercept? Brianna, what about the y-intercept? Does it cross the y-axis at a positive number or a negative number? I didn't hear you. Yeah, it crosses at a positive number. Does everybody see that it's going to cross right here? And that's going to be a positive number. Okay. So now we can actually match up the equations to the graphs. So I'm going to go back to graph number 1. And I'm looking for an equation that has negative slope and a negative y-intercept. What equation there has negative slope and a negative y-intercept? C, negative slope and a negative y-intercept. So this is graph number 1. What about graph number 2? Graph number 2, I'm looking for an equation that has positive slope and a negative y-intercept. What letter choice is that, Lissandro? D. Good job. Positive slope, negative y-intercept. Graph number 2. I'm going to put a circle on those. Okay. What about graph number 3? Graph number 3 is what color? Green. Graph number 3. So I have a positive. What do you think, Owen?
I obviously am leaning towards saying that it's B.
You're exactly right. It is letter B. It is letter B. There is no number attached to the X. We know that if there's no number there, that means it's a what? It's a positive 1. Good job. And my slope is positive, or my y-intercept is positive 5. My last one, by process of elimination, has to be letter A. So let's just verify. Does equation A have negative slope and positive y-intercept?
Yes, it does.
It sure does. Negative slope and a positive y-intercept. What do you think about that?